So today we're going to look at another type of interest, compound interest. So when you talked about yesterday, we're like a credit card charges interest once a year, but in reality they do it more than that. So suppose you charge $1,000 on a card that charges 12% APR. Find the account balance after 5 years. So our single expression from yesterday was 1,000 times 1 plus 12% to the 5. So we would go to Desmos, and then we did 1,000 times 1 plus 0.12 to the power of 5. 1762.34. So in reality, sometimes they're charged different times per year. They check this interest. So semi-annually, instead of once a year, it would charge 6% twice. So what we would do for this is $1,000. So I'm going to say 12%, but it's semi-annually, so it changes it twice, so 6% for 5 years. So 5 years, but they're checking it twice each year. So if we were to put this, we'd have 1,000 times 1 plus 0.12 divided by 2 to the power of 5 times 2. Whoops, and we have to make sure, I think I need to put that in parentheses. So 1,790.85. So we're going to start filling in this chart to see what happens. So annually is once a year. Semi-annually is twice. Quarterly is 4 times. Monthly is 12. And weekly is 52. So the interest rate, so this would be 12%. 12 divided by 2 is 6%. 12 divided by 4 is 3%. 12 divided by 12 is 1%. And 12 divided by 52, 6 over 26, whatever 3 over 26, or whatever that reduces down to. So when calculating this, so our expression would be 1,000 times 1 plus 0.12 to the 5. This one would be 1,000 times 1 plus 0.06, but we're checking it twice a year, so that would be to the 10. 1,000 times 1 plus 0.03, 4 times a year for 5 years, so that's 20. 1,000 times 1 plus 0.01, you're checking it 12 times a year, so 12 times 5 is 60. And then 1,000, 1 plus 12 divided by 52, you're checking it weekly, so that would be 52 times 5. So we can see what happens here. So 1,000 times 1 plus 0.12 divided by, we did it quarterly, to the power of 5 times 4. 1,000 times parenthesis 1 plus, I think monthly was next. So this would be 5 times 12. Whoops, and I forgot to put that in parentheses. Oops, and this should be 0.12. Then 1,000 times 1 plus 0.12 divided by 52 to the power of 52 times 12. And again, I forget to put that in parentheses. So what you can see here is we're slowly making more money the more often that we do this. Times 5, excuse me. So if we were to write an expression here. A equals, we start with this, 1 plus our rate divided by the number of times we charge it to the power of t times n, the number of times it's checked. So monthly would be our principal, 1 plus r over 12, 12 times t. So that is our compound interest equation. Our amount equals our principal, 1 plus our rate over n to the n times t. So let's take a look at a couple of examples here. So more than once a year, you're buying an iPad for $4.99. It's compounded. Here's our interest rate, compounded monthly. How much after 2 years if you don't pay out the debt? So we start with $4.99, 1 plus 0.198 divided by 12, and then 12 times 2. So again, just type those in, watch the parentheses. $4.99 times 1 plus 0.198 divided by 12 to the power of, and we got to put parentheses there, 12 times 2, $7,403.90. That seems a little. Let's check, make sure I typed that in. 0.19. Yeah. Oh, was it $499? Okay, I did 4. I was like, that seems a little much. So $739.06. So let's take a look at this next one. Since 1995, the daily patient care in hospitals in the United States has increased about 4% per year. In 1995, such hospital cost an average of $968 per day. So, how much did it start with? Was $968, 1 plus 0.04 divided by, we're just checking it once a year, and since 1995, so 222 minus 1995, so 17 years to the power of 17. That would be for this year. We just have to write an equation, so my bad. So that should be 0.04 divided by 1 to the x. We could do x times 1. Or we can change this to match our equation to the t. So then it asks since 2018. So this is where we're going to go, 0.04, 2018, so 2018 minus 1995, 3, 23 years, so to the power of 23.